Hey YouTube! I got a pile of stuff sitting here, and if you've read the description or read the title of the video, you pretty much already probably guessed what a lot of this is. So let me move things around, and I'll go through everything one by one. This is the NooElec Mini2, the R820T2 SDR dongle. I got this last week. I made a decision to get into software-defined radio because the price point on these is really good. Just a bit of background for those who don't know what software-defined radio is. Basically, it's putting a lot of the work of a radio in software. What this dongle does is it basically digitizes a big swath of radio frequency. This one will go up to 3.2 megahertz. And then within that 3.2 megahertz of spectrum, you have software like SDR Sharp here that can go through and individually tune signals as well as perform the demodulation. So whether it's AM or FM, single sideband, or some kind of digital mode, it's all done in software. And the big advantage of that, obviously, is, this one dongle will pick up anything in its frequency range without having to, have a special extra circuit. So I can use this dongle to listen to FM radio and then go up and listen to weather radio or listen to ham guys running narrowband FM, all without having to go, well, I need a radio that supports this, this, and this. Which they make them, but they're expensive. I have a friend that, 12 years ago bought a handheld ham unit that did a lot of this stuff, and it was outrageously expensive. Software-defined radio has been around for a while. It's just usually been very, very, very expensive. These were originally sold as DVB-T and FM dongles, designed solely to receive DVB-T signals. Some enterprising hackers, however, figured out that by changing some drivers and not using the manufacturer's drivers, that they could get raw access to the IQ RF signals that the RTL chip was pumping out, and they were easily able to get access to the R820 tuner inside the unit to get free-range tuning. So, essentially, yeah, it's a very cheap, under $20 SDR kit, just for the dongle. I think this one probably retails for around $25 because it's got the newer chip, and NooElec puts, I think when they have theirs manufactured, they use slightly better crystals and capacitors. I saw one on eBay that didn't have the T2 chip for $8.99. And that's, for a software-defined radio, that's a heck of a bargain, considering, like I may have said, some of them go up to thousands and thousands of dollars. But nothing really too fancy here. This looks like a lot of the other ones, except it's blue. It's got the same vent casing design and the LED with the micro coaxial connection on it. It will tune, supposedly, out of the box. These things tune from 24 megahertz up to 1.7 gigahertz. Somebody has found out units with the T2 chip using an even different modified driver, you can usually get down to 14 megahertz or up to 1.8. Some people had success getting down to 10. I installed them. I couldn't get down to 10. So this particular dongle just won't do it. But like I said, for over 24 megahertz, I'm covered. Of course, I'm not really interested in staying over 24 megahertz. So I bought another thing the same company makes. This is the NooElec. They call it the Ham It Up. It is a frequency up converter. It converts 100 kilohertz to 60 or 70 megahertz up to 125 megahertz. And it's a local oscillator with a mixer and some filters. They don't sell it like this exactly. You have to, they sell it, as a board, and you have to buy this metal case separately, which is fine. I think the case was $15. I bought this all as a bundle from them. They actually have, I guess they call it the Mini2 bundle, but you get the board and the dongle, and then of course you get the cable to connect the dongle to the converter board. As you can see, it's got MCX on one end and SMA on the other, and I'm going to set it out of the frame because it's going to fall on the floor. And that's all included in a basic bundle price. And then of course they have extras you can add on, like this $15 metal enclosure, which I have to say, if you're on the fence about it, get it, because this provides quite a bit of RF shielding, and it also means I can carry this thing around and not worry about destroying a board that costs more than the radio. Like I said, this dongle from NooElec is around $25. You can get similar dongles for cheaper. The board itself was $50, so this is about $65 just for the up converter, which is 3 times the cost of the USB dongle. But that's fine, that's sometimes how it works. By the way, this does not work just with the RTL-SDR dongles. If you have, it's a basic oscillator with the mixer. It's a dumb device. It just, you plug power into it, you pick whether you want to pass through or up convert your signals, and it outputs an IF frequency or an IF signal at like I said, 125 megahertz. So you could even use this with non-NooElec SDRs, or you could even use it if you have a scanner or something, and or something with airband would at least get you somewhere close in the general area. I don't have any airband receivers anymore, nor do I have my handheld scanner that would do airband. But essentially, yeah, this is just a frequency converter, and it doesn't require you to have a specific dongle. You can buy a cheap dongle and then buy that. Little confusion around that from people, so I wanted to clear that up. Also in the kit, I bought their 9-to-1 antenna balun. Now, usually you need a 9-to-1 or a 1-to-9 balun when using long wire. And this is actually quite simple. It's just, a couple of spring clips and an SMA female connector on the back. But as I was saying, normally, yeah, you really ought to use some kind of a balun, especially when you're going through an impedance change, because a long wire antenna has an impedance of about 450 ohms, whereas the output of the SMA is only 50 ohms. The problem with this, and I guess it's not really a problem because it works, is that technically a balun takes a balanced signal and converts it to an unbalanced signal. So as a prime example, I'm sure some of you guys might recognize this stuff. This is 300 ohm twin lead. This was used for antennas way back when, and of course, they also were quite popular as, I don't know if you can see it up there, as FM antennas. They made what they call a folded dipole FM antenna. And those usually required a balun. I don't know where I put that balun. 300 ohm to 75 ohm balun. Because the signal that you're dealing with on those antennas is balanced. And usually your FM tuner has an unbalanced input. But a long wire antenna is not exactly a balanced signal. It's an unbalanced. So technically what we would need is an un-un. And I haven't figured out if this is even wired closely to work as an un-un. However, running my long wire into one side of the thing, if I can keep it from falling on the floor, running my long wire antenna input into it, and then running dedicated earth ground into the other side, seems to work pretty well. Of course, I also bought the SMA to SMA pigtail for connecting those. And originally my intention was, I was going to splice this connector in the middle, or cut it and then splice it onto various other connectors. I think I was going to splice one onto an F connector, and I was going to splice the other one onto the included uh, whip antenna, which has the MCX connector. The reason I was doing that is because this has a pass-through. I can leave this plugged into the unit permanently and flip it on and off. Although I have kind of figured out that even in pass-through, the 125 megahertz oscillator causes harmonics. But I was eventually talked out of it by a friend who said you'll never solder coax properly ever. Just don't even try it. So I ordered a couple of adapters. In the meantime, I had ordered this. This is a SMA male to SMA male. I bought this because I was going to use this to connect the Balun to the unit after I cut the pigtail. But since I ordered a couple of adapters that I needed, I think I ordered an F type to SMA female and MCX female to F type female. I decided this really was useless, so I decided to do the next best thing, and I just soldered a wire onto the center conductor, and it doesn't work right. I've hooked various antennas into it, and obviously there is a big impedance mismatch, or I'm just not getting a good connection. I'll probably play with this a little bit more when I have really odd antennas that I'm playing with. But so let me go ahead and take a break here, and I'll hook this all back up, and I'll show you guys what it looks like hooked up and how it works. Alright, so hold on tight. Yeah, it's all gone! I hooked it up. Pardon the mess on my desk. But as you can see, dongle's plugged into the PC. It is really almost a no-brainer connection. You connect that to your IF output, and Balun is connected to my long wire antenna and a dedicated earth ground. And the performance is really quite nice. Let me go back to the proper input here. And I'll hit play on this, and it's going to start off at 100. Well, the frequency says 126.235. I need to flip on the converter because it's turned off right now, and you'll see when I flip it on, I get signals immediately because it's basically turned on the oscillator. Actually, it doesn't turn the oscillator on, it just kind of reconnects it, which, as I said, that's a bit of a problem when using pass-through, because then you get 125 megahertz image bleeding through. Of course, since I'm running 125 megahertz higher, I have to shift my frequencies down. So here we are. You can see we're right around 1240. And I'll zoom out here, and you can see what we're looking at here is you're looking at basically most of the entire AM band. You can definitely see where my antenna is a whole lot more sensitive right around 1200 than it is the rest of the band, mostly due to noise. I don't get that with other antennas, so I know it's not the unit, and it's not the SDR, and it's not my environment. It is clearly the fact that my antenna has so much gain right there that it's all this noise is coming through. But yeah, this is what the AM band RF kind of looks like. You can definitely see this is daytime, obviously, so it's all mostly locals. You can see this is 570, this is 630, this is probably 780, this is 820, 920, this is 1190, this is 1310, 1420, and 1460. 1460 is a local 5,000 watt powerhouse that I'm a few miles from. This bleeds through, and I'll use this as examples in other videos because you can see how it's nice and wide, very loud. But basically, what this thing is doing is it's digitizing. I think it's set right now to like 1 megahertz of spectrum here. Actually, 1.5 megahertz. This is 1.5 megahertz of spectrum. If I drag this down, I could show you literally the entire AM band, which starts somewhere right in this area and runs all the way up to there. And basically what I can do is I can click on a signal. For example, I can go down here and I can click. I mean, you can literally just click on anywhere in the spectrum and it'll go to it. That's a pretty good song right there. Which is really cool. But like I said, the main thing about this is that you're doing all this in software. So you can tweak your reception of things a little bit better. You could also do things like run the wrong kind of mode, because sometimes with some AM signals, you get better copies on them when you run them in single sideband mode. And I'll talk about that in another video. Of course, the really awesome thing about this, and I'll demonstrate this to you guys, is we have the ability to record what they call IQ baseband data. What that dongle literally does is it sends 1.5 megahertz of data to the software. We can actually record that. They call it IQ baseband, or some things just call it baseband. But I can actually record the baseband. And I'm going to pick 8-bit PCM. You might be thinking, why pick 8-bit PCM? Well, there's two reasons. A, we're not recording audio. We're recording RF. Different rules. Secondly, the ADC, the RTL-2832 chip, only has 8 bits of resolution. So these files get large enough. So here's what we're going to do. I'm going to turn this up a little bit so you can hear what it is. Yep. Okay, so they're playing some Carly Simon over here. Down here at 6:30, you got Rush Limbaugh. Here's some sports talk and a couple things. So what I'm going to do is I'm actually going to sit here. I'm going to sit here on AM 1200. I'm going to sit here right in the middle. And I'm going to go down here. And I apologize. I would be screen capturing this, but the SDR software takes up so much processing power, I don't have enough left to do it. So let's go ahead and record this. And we're going to record, about a minute or 30 seconds of it. And in fact, I'm going to go ahead and jump around the band. I can go over here and see what's on 1310. Oh, classic Christmas Carol with Asian talk over the top of it. I don't mean anything by that. I can't identify what language it is. So yeah, I'm doing this to prove a point. I'm sitting here on 1310. Okay, we've been recording for 36 seconds. I'm going to stop the recording. I'm going to go ahead and go up here, and I'm going to stop the SDR, and I'm going to change my radio type to a wave file. I can go ahead and pick up the IQ wave, and this is the wrong folder. I need to go back and pick the right folder, which I copied to this drive because these files are large. So you can see here's our file. The center of it was 1067 kilohertz, which is not critical. So I'm going to go ahead and load that, and I'm going to go ahead and play it. And now we basically hear everything we heard before, except I can go down here and tune 1190 again, or I can go down here, I can tune 1420. Because it is literally recorded the entire megahertz and a half of spectrum, and now all I have to do is go back, load it in the program, and I can scan the entire band just like it was live, regardless of what I was listening to at the time, which is really handy for many, many other cases. I just can't think of many. So, like I said, it's been a big learning curve on this, learning how to pick out weaker signals using single sideband mode. And I'll talk about that in another video, because I have learned quite a bit about AM reception in the last few days that I've had this, mostly why mine has always been so borderline poor. So anyway, I'm approaching 20 minutes, which is probably one of the longest videos I've ever sat here and talked about something. If you guys decide to buy a setup, I highly recommend NooElec, but I'm not going to say they're the only ones. The Hammond Up converter is probably one of the better ones on the market. There are a lot of converters out there. There are a lot of units that have been modified to use what they call direct sampling. And really the direct sampling method doesn't seem to be as efficient as using an up converter. So, yeah, just in case you've been wondering what comes with the NooElec bundle or how well it performs, there you go. I will do one more little video here. One more little thing on the video. If I can find it, I think this is it. I want to say this is it. This is a recording I made last night. Or maybe I didn't. I don't know what I was doing. Why did I record 10 megahertz? I think my software has become highly confused. Yeah, something's not right. I actually got a copy of WDJO 1480 out of Cincinnati on this thing last night. And the amazing part about that is WDJO only puts out a whopping what is it? 300 watts at night, I believe. Yeah, 300 watts in the middle of the night. That's all the signal they put out, and that's basically what we've got here. Okay, here's another good example. I did this one a couple days ago. I don't remember what exactly I was recording. Oh yeah, I was recording this station here, I believe. No, the one next to it. Just because it was there. This is a couple nights ago. This is in the 3 megahertz range. The neat thing I can do to verify that is if I go over here in the spectrum, if I can get this thing to move, come on! I thought I saw it on here, and yeah, here we go. That is CHU on 3333. That was recorded because it was in close proximity to this station. Which, it's not 7 hours, 37 minutes. It's, what was that, 18 hours, 55 minutes? So, that should hopefully demonstrate just how cool this thing is. I was really wanting to show you WDJO, but I apparently don't have that on here. I was pretty sure. I know why I don't have that on here, because that is in the other folder. So let's go back and let me pan down here so you guys don't see the contents of my download folder. Not that I'm worried about there being anything incriminating in there. It's just one of those things. So here we go, 1480. These are the audio frequency files. So here's one of them, and I'll click on this and I'll open it up. I'll play it again, and I'll retune 1480, and that is WDJO. It was really hard. It was really difficult to get a copy on it. I had to wind up doing that in sideband mode. But I can show you, I actually made an MP3 of it, of the signal copy that I got on it. I gotta say, that's pretty impressive for a under $100 setup. Now, granted, I got a 300-foot antenna on it. Anyway, I'm rambling on. This really has been one of the coolest things I've ever purchased, and I've always been a radio geek. I've always been a computer geek, and the two normally never got along very well. But now they have, and it's been an outstanding amount of fun. Just completely, totally, way too much fun. I mean, I'm spending I'm spending so much time down here at night DXing on the 40 and 80 meter bands. It's insane. So I'm gonna get out of here. I'm gonna listen to some radio. Actually, I'm gonna get ready to do another video on the problem with AM DXing at night now, thanks to HD radio. So hey, I hope you guys have a good one. Thank you for sitting here and listening to me ramble and rant and ramble for the last 25 minutes. Even if you didn't learn something, I hope you found it halfway enjoyable. So take it easy and happy holidays, everybody.